Alright guys, so let's take a look at today's work. It's not that new, because you guys kind of have seen things like this in Algebra 1, but I'm tweaking it a little bit, so it's a little bit new. So it's not that new, but a little bit new. But I'm assuming that we can learn just by doing it, so we're not going to take notes on this. The way we're going to simplify a radical, right? People usually call this square root, because there's an imaginary 2 on the outside, right? Square root. But it could be a 3, it could be a 4, it could be a 5. So I'm just going to call it a radical. What we do first, let me think of any two numbers that multiply equals 20. What numbers can you guys think? 2, I heard 2 and 10. Right, it doesn't matter which two. It could, there's other choices. But then, let me split up the 10. Which two numbers multiply equals 10? 2 and 5. Alright, so let me put the 2 and the 5. Usually, for square roots, when we don't see a number, we imagine the little 2. What that little 2 means is that I'm going to get my numbers that I got down here, I'm going to get my numbers in groups of 2. Right? If I had a 3, get them in groups of 3. If I had a 4, get them in groups of 4. So I'm going to get it in groups of 2 of the same number. So I can get a group. And then the way I'm going to write this, right? I'm going to write the radical symbol. And then think of this as a house. You know, there's an inside and there's an outside. But for the numbers that go out, related to movies, right? When you guys are groups, whether you guys got friends, boyfriends, girlfriends, whatever, your groups, you tend to go out, right? You guys go to the theater. So I have a 2, which is a group, and there's already a 6 on the outside. Let me multiply those out. How much is 2 times 6? 12. So I have 12 on the outside. Remember groups? No, there's no. So multiply the groups with the outside, right? The groups with the outside number. So that's how I got the 12. See how the 5 is a single? So I was not able to get that in a group. Leave the 5 inside. Once again, like I told you guys in movies, the groups go out. Those of you that are single, stay in. You stay home watching Netflix. So relate that as into, like the movies. I'm using that as a relationship. Groups go out, singles stay in. Great. Thank you. But let me make it a little bit more difficult. Let me take a look at question number 2. Give me any two numbers that multiply equals 384. I heard a 2 because that's an even number. Yes. 2 times what? 192. What is it? 192. Yes. And since we knew 2 was one of them, we just went 384 divided by 2 and gave us 192. All right. What about 192?
No, we do 4.
We could do 4. Okay. 4 times what? 4 times 48. Okay. The 4, 2 times 2. There's already a group here. I'm just going to put them those so I can keep them together. What about 48? Which two numbers multiply equals 48? 16 and 3? Okay. I have no groups yet. What about 16? What was it? 4 times 4. Okay. I know my 4s can split more, 2 and 2 each, but my goal is to get them in groups. So as soon as I already have a group, just group them up. Our goal is not to break them up. Our goal is to group them up. So like I said, as soon as we have a group them up. Okay, now that I finished, I have more than one group. Like, I know question number 1, I only had a group. Question number 2, I have more than one group. When that happens, multiply your groups. So 4 times 2 gives us 8. Times the number on the outside, what do we get? 80. Alright, so on the outside, I'm going to have an 80. Once again, we multiply the groups, and then we multiply with the outside. On the inside, if you notice, I have 2 singles. 2 and a 3. When we have more than one single, also multiply them. So I'm going to finish with a 6 on the inside. So 80 radical 6. Once again, my groups go out, my singles stay in. If you have more than one single, multiply them out for the inside. If you have more than one group, multiply them for the outside. Just if there was a number on the outside to begin with, so obviously multiply your groups to that. Yes.
So it has to have one digit if it's like a single, or
It could be two. It could be two digits because if I had a 3 and a 5 singles, then I'll get a 15 on the inside.
but like if you're trying to find out what you need to multiply to get the what's inside the round, do they have to be like one digit?
One number, you mean?
Like no,
Like,
whatever you multiply to get what's inside the radical, do they have to be one digit?
not necessarily.
Okay.
Because like I'm thinking if I had two singles, one was a 3 and the other one's a 5, then it becomes 15, which is two digits. So no. Okay. Any questions on the first 10?
I still don't get how is 80 and 6 the answer?
Yeah, 80
How did
radical
you
6.
get that?
How did I get the 80?
Yeah.
Okay, first, multiply your groups. 4 times 2 gives us 8.
Mm-hmm.
But then there was already a 10 on the outside. Multiply that as well. So 8 times 10, that's how we got the 80.
Mm-hmm.
Now for the 6 on the inside, I'm looking for the singles. We had a 2 and a 3.
Okay.
Right? The singles are those that we're not able to get in a group. 2 and a 3, multiply them. That's how I get the 6. So groups out, singles in. Alright. And one thing, like I mentioned earlier, our goal is to get groups, not to split them, to get groups. So the 4, group them up correctly. Alright. Any questions on the first 10? Number 3? Alright, let's take a look at question number 3. 108. Give me two numbers that multiply equals 108. 12 and 9. Alright, what about 12? 6 and 2. What about 6? 2 and 3. I'm just going to put them like that so I can group up the 2's. What about the 9? 3 times 3, that's another group. Alright, so on the outside, your groups, multiply your groups, in this case 3 times 2, multiply your groups, and then also multiply to the number on the outside. So, remember when we multiply our group is 6, right? 3 times 2, 6, but also multiply to the number that was on the outside to begin with. How much is 6 times 9? 54. So on the outside is 54. On the inside, we just have the 3 left. Because there was only one single. Remember, I'm only looking at the numbers I was not able to split anymore. So like the 6, the 12, and the 9, I'm ignoring them because we split them.
So you don't multiply the whole the two groups together. You can multiply one each.
Yeah, one per group.
Okay.
The 3, the single.
So you always do the
But
single
six
one?
is single. No, three. Six is single too. What about six?
Remember, the
Oh,
6
wait,
was
no.
split. The 6 was split. So I'm only looking at the numbers I was not able to split.
So that's give her two.
Here's what two.
Has to be like an odd.
Doesn't have to be an odd. It's just that groups. I'm looking for the outside groups only.
Oh, alright.
Right? I see a group of 3, I see a group of 2. Multiply your groups. But I also multiply the number on the outside. Remember, because the 6 is going to go out. For the inside, I only have a 3. It doesn't have to be odd, because I did question number 2, the single was 6, right? So that was, we got an even number.
How'd you get 54?
Multiply your groups, 3 times 2. So 6 times a number that was already on the outside. 6 times 9.
Shouldn't it be like 4 times 9?
No, because you're getting only one per group. So this is a group of 2's, this is a group of 3. Don't go 3 times 3 and then 2 times 2. Just go 3 times 2. Like one per group. It's a group of 3 and a group of 2. 6. So this is 6, but see how there was already a 9 on the outside? So 6 times 9. I guess you could consider the 9 on the outside to begin with, consider that a group, because that was already out. Yes. Alright, let's take a look at number 6. Let me take a look at number 6. 144. Give me any two numbers that multiply equals 144. 12 times 12, okay. I know we can split them more, but I'm not going to split them because I'm already going to get them in a group. So I have a group of 12 times the 7 on the outside. How much is 12 times 7? 84. I have no singles, right? In a perfect world, we will have no singles. In a perfect root, perfect square root, we have no singles. So there's nothing in root. It's just 84. It's just 84. Right? Because we have no singles.
What about like if you get like two of them that are both outside?
Multiply your groups. Kinda like, I think we got that in question number 3. I had a group of 3 and a group of 2. Multiply 3 times 2. Multiply your groups.
Because like I have one circle, but the other one is the two outside and the other three outside.
Which question are you looking at?
Or
Yeah, me too.
Alright, let's take a look at question number 4. 150. Which two numbers multiply equals 150? 10 and 15. Alright. What about 10? 2 and 5. What about 15? 5 and 3. So we have a group of 5, right?
yeah.
See the 7 that was already outside, consider that a group. The 7 that was outside to begin with. So 5 times 7 is 35. If I have more groups, obviously multiply by those. On the inside, multiply your singles. 6. Remember, groups go out, singles stay in. Makes more sense, huh?
Yeah.
Alright, now that you know how to simplify radicals, we're going to look into the distance formula, looking at question number 11. We need to know how to simplify radicals for this. But before I look into the distance formula, let me remember the slope formula, right? You guys remember that from algebra 1, y2 minus y1 over x2 minus x1. Remember that from algebra 1. So let me come over, let me act as if I'm going to get the slope. And I remember from the slope, in this case it would be negative 1 minus 3 over negative 6 minus 7. Remember that from algebra 1? Right, y2 minus y1 over x2 minus x1. Alright, and when I simplify this, I get negative 4 over negative 13. Right? So this is as if I was getting the slope. Here I'm asked, find the distance between each pair of points. The distance formula is going to be a square root. That's why I had you guys simplify square roots. And on the inside of this square root, in my case, I'm going to go 4 squared plus 13 squared. You see where I get my 4 and my 13 from my slope? Right? I ignore the negative sign because once a number goes square, it becomes positive, right? Right? Square number is positive, so I'm ignoring the negative sign. So I just wrote 4 squared plus 13 squared. I know 4 squared is 16. So I have inside 16. 13 squared is 169. How much is 16 plus 169? 185. So you guys see what I did? 4 squared plus 13 squared. Simplify it to just square root of 185, right? But then you know how to simplify radicals. That's what we did on the first 10 questions. Okay, so give me two numbers that multiply equals 185. 5 is one of them. 5 times 37. Good. The 5 I cannot split it anymore. The 37 I cannot split it anymore. So I get no groups. Since there are no groups, the square root of 185 was already simplified to begin with. Right? The groups go out, but if I'm not able to get any groups, nothing goes out. Yes.
If we don't have enough room on here, can we get a second one?
Yes. Yes.
Please.
Please. Let me take a look at question number 12. To look at more examples. I'm going to start first with negative 4 minus 4 over negative 1 minus 3. Right, I'm acting as if I was getting the slope. Y2 minus y1, x2 minus x1. So I get this as negative 8 over negative 4. Right, did I lose anybody? No, we're good?
Yeah.
Back in the slope, they will tell you simplify your fraction, right? With the slope, but with the distance formula, don't. For the distance formula, I'm going to get the square root of 8 squared plus 4 squared, right? Do not simplify your fraction. So that is the square root of 64 plus 16, which is the square root of 80. You guys with me?
Yeah.
All right, so let's simplify this again.
Every time you put it in there, they're always going to be positive?
Always positive. Because the reason why is when you square it, it becomes positive, right? So always write it as positive, yes. All right, so square root of 80. Simplify that. Give me two numbers that multiply equals 8. 8 and 10, all right. What about 8? 4 and 2. What about 4? 2 and 2, so we already have a group. What about 10? 2 and 5. We have another group. So what do I get? Not an 8. 4. On the outside is 4. On the inside, 5. So 4 radical 5. Okay, if you guys are still wondering, the 4, we multiply our groups 2 times 2. Keep in mind, I'm considered as a whole number, not the group of 2 times a group of 2. 2 times 2 is 4. And then the single stay in. So 4 radical 5.
You have to draw it after each other.
Yes. I still see some faces, so let me take a look at question number 13. Let me go 2 minus 8 over negative 2 minus a negative 1. 2 minus 8 is negative 6. How much is negative 2 minus a negative 1? Close? Close? Negative 1. Negative 2 minus a negative 1. Remember, two negative signs becomes a plus. Negative 2 plus 1 is negative 1. Alright, so I'm going to go the square root of 6 squared plus 1 squared. So 36 plus 1, which is the square root of 37, right? You know, can we split 37? So nothing's going to come out. So good. So we're good now? But again, any questions up until number 20? We're good? Yes.
On number 7, I already did the. I got 14 times 14. So if there's like no like singles, you just put 0.
Nothing in there. Remember, there are no singles. We call it a perfect world. No singles, so don't do anything on the inside. So for number 7, you have 14 times 9, right? Which is what, 126? And there's no singles, so I'm not going to write my square root. Because I have nothing to go in. Alright, any other questions up until number 20? We're good?
Yeah.
Alright, now let me look at the distance formula using pictures. So 21. To begin with, let's say that I had something like this. If I had given you a question like this, just count the spaces. And I'm asking you what's the distance between each pair of points. If I have given you something like this, just count the spaces. 4. So let me not take a look at the easy questions. Let me take a look at the hard questions. Something like 21. Alright, one thing we can do, we can get the coordinates. The coordinates of this is 0, 5, The coordinates of the other one are 2, -5. And then we can treat it the same way we're treating questions number 11 to 20. I can just go 5 minus a -5 over 0 minus 2, which I get 10 over -2. And then I'm just going to go the square root of 100 plus 4. What was it? For the slope, simplify. For the distance, stuff. So I'm just going to go 100 plus 4, right? 10 squared plus 2 squared, 100 plus 4, which is 104. All right, any two numbers that multiply equals 104. 52 times 2, all right. What about 52? 2 and 26. All right, we have a group. What about 26? 13 and 2. Nothing can split up, so I'm just going to call this 2 radical 26. My 2 is my group. My 26 are my single. Yes. 104. Well, 10 squared, it's 100. 2 squared is 4, so Adam is 104. Yes. Okay, so 25 plus 1 gives me 26. So what about my single? I mean my group. So don't simplify. Okay, some of you might be like, well, can we do it a better way with the graph? Yes. There's an easier way with the graph. If I create a triangle, you notice my bottom number is 2. The distance, if I look at here, is 10. You see my 10 and my 2, which is, I'm going to get my numbers down. If you don't like to subtract y2 minus y1, x2 minus x1, if you don't like to subtract it, form a triangle, and your two numbers are there. So let me take a look at number 22. Now 22 is easy, and 23 as well. Like I said, I'll leave the easy ones for you. Let me take a look at number 24. Right? If I don't want to do the y2 minus y1, let me create my triangle. My distances are 1 and 3. Right? If you guys get your slope, it would be like 1 and 3. So I'm just going to come over and I'm going to go the square root of 3 squared plus 1 squared, which is the square root of 10, right? 3 squared plus 1 squared is 10. Can we simplify 10? Right? 2 and 5. So it gives me 2 and 5. But neither my 2 nor my 5 can split even more. And I have no groups. So that means radical 10 was already simple to begin with. Are we better now? Let me take a look at number 25. If I create my triangle, I notice my measurements are 7 and 3. So for my triangle, for my square root, I'm going to go 7 squared plus 3 squared, which is 49 plus 9, which is square root of 58. All right, can we split our 58? 2 and 29, right? Can we split either our 2 or our 29? No? That means square root of 58 was simple because nothing was able to come out. Remember, I was not able to get any groups, so nothing comes out. Is it easier? Right? Any questions?
How did you get 7 and
3?
7 squared plus 3?
If you look at my triangle that I created, my measurements are 3, right? Just kind of squares, and 7, right? So for my formula, I'm going to go inside the square root, 7 squared plus 3 squared, which is 49 plus 9. Right. 49 plus 9 is 58, so I'm looking at the square root of 58. But then simplify it if possible. This one we were not able to simplify because we were not able to get groups. Our groups go out, we were not able to simplify it. Just to see if you guys are getting this, let me do one more. Let's take a look at number 26. Let me take a look at my triangle. My numbers are 3 and 4. Right, those are my measurements. 3 and 4. We can count the squares. So I'm going to go 3 squared plus 4 squared, which is 9 plus 16. How much is 9 plus 16? 25. So let's break out the 25. Which two numbers multiply to 25? 5 and 5. So that goes out. I have no singles. So this is what we call the perfect square. Where nothing stays in. Everything went out. Because we have no singles. So just 5. And my answer is just 5. Right? Because there are no singles in this